So, from the title of this lecture, I think that you guys have understood that here I will only talk about the oxidation and reduction reaction in organic chemistry. So, throughout my lectures, I will try to cover from very basic to advanced reaction in organic chemistry. Okay, so when we talk about any oxidation and reduction reaction, which picture should come in our mind? Electron transfer reaction. Okay, so we can say, okay, just a minute. So any oxidation and reduction reaction, particularly any oxidation and reduction reaction, if we talk about either in organic chemistry or in inorganic chemistry, you will see one thing, that every oxidation and reduction reaction is basically a redox reaction. And in most of the cases, not in all cases, but in most of the cases, you will find that some electron transfer is happening from one species to another species. If we just take a very simple and well-known example of oxidation reaction, but I can say that if we keep the iron in presence of air and moisture, what will happen? Rust will come. So how is it coming? It is basically an example, it is basically an example of oxidation reaction, redox reaction. Okay, so this thing you should keep. Okay, so that is very much important, that how we can introduce the redox chemistry in organic chemistry. Okay, so in organic chemistry you will find that numerous types of numerous types of redox reactions you have to encounter one by one in later stages. But prior to go to the detail of a reaction, I think we should make a solid background of this particular topic. Let us start. Okay, so for oxidation reaction, if you see the oxidation reaction, what do you mean? Oxidation means is nothing but release of electron from any species, and reduction is just the opposite of oxidation. That means accept of electron by any, I think that you know this thing. Okay, but in organic chemistry, I think not only in organic chemistry but also in inorganic chemistry also, I think you have encountered several reactions where you must encounter the dehydrogenation process. Am I correct or not? I think I am correct. Let's say if we take CH3, and if we just perform dehydrogenation process, means if we take out two hydrogens from this particular molecule, it will form CH2 double bond CH2. So basically here you will basically from superficially, if I ask you, any electron transfer process is happening. Okay, so you will say no, because only dehydrogenation is happening. This is also, we can consider it as basically oxidation process, because it is releasing hydrogen. Let's say from here, if we do the dehydrogenation, so what will happen? We will get basically acetylene. We will end up with acetylene. This is also an oxidation. This is also a process of oxidation. So in organic chemistry, when we say or when we consider a particular reaction as an oxidation reaction, that is very much important. Let's say we have CH3, or very simple example I would like to take here. If we take just a methane, if we incorporate some heteroatom means what? Let's say we are incorporating one fluorine atom, so it will be converted to CH3F. That means the oxidation, we can say that this is also an oxidation, because you will find, if you calculate the oxidation number over carbon, then you will find that oxidation number has basically increased. I think that everyone has already gone through how to calculate the oxidation number of a particular atom present in either in a radical, it means inorganic radical, or something else. But in the textbook, you will not frequently encounter the calculation of the oxidation number of a particular atom present in organic molecule. So today in this lecture, I will also teach you that how you can find out the oxidation number of a particular atom present in organic molecule. There is some rules that had been proposed by different scientists, and we will learn those things step by step. Okay, so in organic chemistry, you will say that, let's say we have methane. Now any heteroatom is getting substituted one by one, and we are basically eliminating one by one hydrogen, and we are basically introducing one by one heteroatom. Then basically that process we can consider as an oxidation process. Okay, so let's say we have methane. I have already told you that if we just substitute one hydrogen atom by one fluorine atom, this is also, you can consider it as an oxidation process. Okay, in later stages you will find I will discuss several oxidation reactions. Basically in this particular lecture, or throughout this series of this lecture, I will discuss about the oxidation of, let's say, any alcohol. So basically, let's say we have ethylene molecule, okay, and now we want to do epoxidation reaction. That is also an oxidation process. I will discuss about those things. So when you will find that in place of any hydrogen atom, let's say in case of methane, you have already, I have shown you that in place of one hydrogen atom, this fluorine is coming. So this is basically an oxidation process. Okay, so the thing is that replacement, let's say we have another example I am giving. Let's say we have ethane, right? We have ethane. Now from ethane, if we just try to convert it with something else, let's say CH3, CH2, X is a heteroatom. This is basically nothing but heteroatom. So this is basically an oxidation process. I think it is clear. Up to this I think everyone has understood the oxidation and basically I have not talked about reaction much here. I have only told you the how to basically judge judge an organic reaction as oxidation reaction. I have already told. So two key points you should keep in your mind. First thing is that if any from any species you have if you find out that the electron is going out from that species, then you can say, so basically in case of oxidation we can say that if we talk about oxidation then we have to keep two things in our mind. First is basically release of electron. Second point is that removal of hydrogen. Third point is that introduction heteroatom in place of either H atom or C atom. Okay, so then we can consider it as basically oxidation. We are taking one example, very common example. If we talk about this thing, just try to understand. Let's say we have CH4, then from CH4 to, if we go to, let's say, CH3OH, this is basically oxidation. Then from here, if we go to just, let's say, CH2O, this is also an oxidation process. Then let's say we are going to HCO2H, this is an oxidation process. And from here to here, if we are going to CO2, here also an oxidation process. So what is happening basically? What is happening is basically introduction of oxygen atom and release of one proton. Introduction of another, basically here what is happening? Only removal of proton, that is also an oxidation process. Here what is happening? You see there are two protons, one proton. So basically here also the same thing is happening. So the thing is that I have already mentioned that either you have to remove hydrogen, then you can consider it as an oxidation reaction, or you have to introduce some heteroatom in place of hydrogen atom or any carbon atom, then you can consider it as oxidation process. I think up to this it is pretty clear to all of you. I can't basically see you, yeah. So that's why I think I am basically assuming that you have already understood all those things, that when you can consider it an organic reaction as oxidation reaction. Up to this I think it is clear. Okay, so now I will basically introduce a very unique concept, that is very fundamental concept, that how to basically find out the oxidation number of a particular atom present in any organic species. So I am writing two names, basically two scientists' name. Okay, so they have introduced this concept of finding out the oxidation number of a particular atom present in a particular organic or particular in a organic molecule, right? So the name of the two scientists is basically Soloveichik, Solovik, and these basically these two gentlemen or professor, they have introduced basically 5 criteria that could be used to identify an oxidation process. So first thing is that basically what they have done, basically they have introduced how to charge first thing is that change in oxidation number. Change in oxidation number means, as you know, that if during the course of any reaction, if oxidation number increases, okay, oxidation number, I am just ON, okay, I am representing oxidation number as ON. If you found that oxidation number is increasing, is going up, that means oxidation process is happening. Oxidation process is happening. Second is ratio of dipole moment, that is called, I think, mu by bond ratio. Okay, L means bond length, ratio of mu means dipole moment, L means bond length. So let's say some species is getting oxidized, okay, so then what will happen? The thing is that basically that the dipole moment of the particular molecule will change, as well as the oxidation number is increasing, that bond distance will also change. So from that particular ratio we can also comment on the oxidation process, okay. And there are two more functions. I think that we are not going to that aspect, because that is totally based on physical organic chemistry. So that is called the Hammett sigma function. I am not going to the detail of that thing, because we can make a separate lecture on that particular thing. Now, how to basically determine oxidation number, that is very much important to know. How to determine oxidation number. Okay, if I ask you that, can you find out, guys, can you find out the oxidation number of manganese in this particular radical permanganate? So can you find out? You can easily find out, because you know that what you have to do. Let's say I don't know, so I will consider it as X. Then you know that oxygen has always, it possesses -2 charge. So what will do? It will do one thing, plus -2 into 4 equal to -1. Then x -8 equal to -7, and then from here you can easily find out, very sorry, that will be -1, very sorry. Then x equal to +7. This is basically inorganic species. You can easily find out the oxidation number of manganese, because I think that you have already gone through how to find out the oxidation number of any metal system in a particular present in a particular radical anion or radical cation from your basically class 11th or 12th standard book. I think that, I hope so. But I think that you have not encountered basically encountered the counting of oxidation number of any atom present in any organic species. That basically there is some tricks, or you can say that there is some rule. Okay, there are some rules that I am going to discuss it now. Okay, so basically oxidation number of carbon in any hydrocarbon, you should consider it at 0. Means, let's say if you talk about CH4, now you can say that the oxidation number of carbon is basically 0. You should consider it. Okay, so oxidation number of this is basically 0. I think you have already understood. Okay, oxidation state is increased by 1 if hydrogen atom is replaced by more electronegative hydrogen atom. That means what I am trying to say is that, let's say oxidation, okay, first thing is first. Second thing is that I am just explaining all the things in detail, how to find out all the things. Okay, that is very much important. I am going through all these things. Let's say we have CH4. Okay, from CH4 we are going to CH3 OH. Then how we can calculate the oxidation? The rule says that if you incorporate one heteroatom, then oxidation number is increased by a factor of 1. So here oxidation number is 0, oxidation state is oxidation number, not oxidation state is 0 over carbon. Now the oxidation state over carbon is basically plus 1. So here oxidation number is 0, and now it is increased and it has become plus 1. If we further increase the oxidation, just let's say after, if someone use CH2 double bond, now what will happen? Now there is a trick. What is the trick? Trick is very simple. So rule is, when carbon is attached to any positive, means let's say hydrogen atom, so then for hydrogen atom, consider there are two hydrogen atoms, so -1 into 2, that is -2, and for oxygen atom it will be, what will happen for oxygen atom? Can you tell me, for oxygen atom how we can basically how we can find out the oxidation number? That is very simple. That will be basically the oxidation state over the carbon atom in formaldehyde will be +1. That will be basically +1. How? If we just, let's say, so this is very simple. Let's discuss about one by one. For hydrogen atom, that is basically -1 into +2 -2. For oxygen atom, what will happen? That is basically, that will be +1, means here will be, it will be +2. So total charge, if you say that -2 +2, that becomes 0. So from +1 it has become 0. We can do it in a another way. How can we do that? CH2 double bond. Okay, so if we just try to draw the structure, okay, so let's consider the X. Okay, oxidation is state is X. Okay, so then hydrogen will always provide positive charge, so X, that will be +2, and for oxygen that will be -2, so total it will be 0. Okay, same result, similar result. So then let's say from CH2O, let's say from CH2O we are basically we are getting AC, the further oxidation is happening. So what will happen? Very simple trick. For hydrogen, for basically for this hydrogen, what will be the contribution? Let's say this is X. If we try to find out, this is X. So then X, if we consider if the oxidation number of the carbon atom is X, then we have to follow different thing. But if we just try to, we are not basically considering X, if we try to find out directly, then the thing is basically the magnitude will change. Here, as we are considering this X, means oxidation number as X, so then for hydrogen we will consider it as positive. But if we try to directly find out, then hydrogen will be negative, right? So then let's say X, then -1, right? X X plus 1, okay. Then there is OH, that means for oxygen what will happen? This is -1, yeah, 1 plus 1 and -1, then this for this will be -2, right? So oxygen, when it will present as OH, that will contribute -1. So we will obtain X plus 1 minus 1, X minus 2 equal to 0, then X equal to +2. So the oxidation state of this particular system is X equal to, this is basically nothing but +2. I think I am clear. Okay, so in this particular, so first thing, if you, there are basically two ways to find out either by just consider, let's consider oxidation state of carbon is X, okay. Then oxidation state of hydrogen will be, each hydrogen will contribute +1, okay. Second, if oxygen is connected to C atom by double bond, then it contribute -2, if oxygen atom is connected or bonded by sigma bond only, then it will contribute -1. Okay, so two ways. So first, this way is basically okay. So this is basically first way, and this is basically direct process. Indirect. This is not direct. This is indirect. And direct, if you consider, for direct, let's say HC double bond OH. How we can find out the oxidation number over carbon? Simple, I told you. For hydrogen, if you are going to direct way, so then for hydrogen you have to consider it. This is -1. For this oxygen it should be +1, and this oxygen it should be +2. So then in total what will happen? -1 +2 +1. So then +1 -1 will go, and we will get +2. I think that this part is over. Okay, now we are just try to encounter another problem. Let's say we have this particular system, hydrogen and hydrogen, and let's say we are doing MCPBA-CH2. So now we talk about this particular reagent in our later stages. So here what will happen? Let's see. Very sorry. That is basically MCPBA. That is basically nothing but the epoxidizing agent. So what will happen? What we will get? C. There will be oxygen. Okay. And let's say there will be hydrogen. There will be hydrogen. Yes. So what do you think, that is this an oxidation process? Of course this is an oxidation process. Okay, so what we will get? We will get very simple thing. Okay, how we can basically find out the oxidation number? So see, carbon, that is basically connected or bonded with one hydrogen, and I have already mentioned that when hydrogen will be attached, then if we go to direct method we should consider it -1. So it is also -1. Now this is basically getting oxidized. So now you see, this is basically giving -1. Okay, and here what are you getting? Tell me. So this is basically contributing +1. So total oxidation is basically number is 0. So this is also 0. So -1 is getting converted to 0. This is basically oxidation process. This is an oxidation process. So from this particular up to this, I think that you have learned a very important concept, basically how to basically find out the oxidation number, and what are the rules to define a reaction, an oxidation reaction. Also we have also understood that basically the effect of the introduction of heteroatom in a particular molecule. Okay, so basically I want to also give another example. Let's say if we ask you one very simple question, let's say CH3X, then RCH2X, then R2CHX, then R3CX. What is happening? Basically, the one thing you should keep in your mind, okay, that the electron deficiency, this is very important point. Electron deficiency As soon as it will increase, the oxidation state will also increase, and so this is very important. So from here, how the oxygen, because if I ask you, you will see from the basically superficially, if we look into this but four molecules, four systems, what you will say if I ask you about the oxidation number of over carbon atom? Can you tell me? You will say everywhere carbon is bonded with one particular heteroatom, that is X. So then the oxidation number should be same, but not like that. See, there is a very important thing. As we move from this side to this side, the number of alkyl groups gradually increase. That means if we just write is at electron ED is getting decreased. As soon as ED is getting decreased, then oxidation state is also getting decreased. Okay, so from this concept, if we just extrapolate it, let's try to find out basically find out the oxidation number of very common molecule. Okay, let's say if I ask you H2O2, what should be the oxidation number? What should be the oxidation number? Actually, let's try to draw the H2O2. H2O2 structure is something like this, as per I think something like this. Okay, so H2O2 is like it forms this type of structure, like kind of open book structure. Okay, this forms open book structure. Okay, so basically if you this is kind of open book structure. Okay, so from here, if I ask you that what should be the oxidation state? The oxidation state, I already mentioned you, when it is connected with one hydrogen, that will be basically nothing but the -1 and -1. Very simple, very simple, very simple. I don't know. So basically hydrogen H2O2 means oxygen atom has an oxidation number -1, because as soon as it is connected with same, I told you that hydrogen means what? -1. Hydrogen means what? Minus means contribution, not minus. Contribution towards the oxygen atom, contribution. So it will be -1. And also you can do in a different way. So let's say if you consider X, then you should consider X plus 1 is equal to 0. This is for hydrogen. Direct method is different, indirect method is different. X minus 1. This is another example. Let's do another example. If I ask you what should be the oxidation state of OF2, sorry, OF2, can you tell me? Here the electronegativity that is basically chi. So chi fluorine is greater than chi F, sorry, chi oxygen, right? So that's why if I try to find out the oxidation number of our oxygen, so what will happen? So then X indirect method -2 equal to 0. Here oxygen is basically the oxidation number over oxygen is +2, because the electronegativity of fluorine is higher than. Let's say if we discuss about ICl, what will happen? ICl greater than, that means this is +1. X plus 1 equal to 0. HCl equal to -1. I think up to this you have understood, right? Okay, so today I think what we have learned so far, we have learned very important 3 to 4 concepts, very important concepts. Is basically I am writing one by one. Just try to gauge it. Okay. Summary. First thing is first. What is oxidation and reduction reaction? How to basically consider, or better how to identify oxidation reaction, how to find out oxidation number of any atom in an organic molecule. Along with that, the last thing is the examples. So up to this, I think everyone has understood so far. I think you have understood all the concepts whatever I have discussed here. So in the next class, I will try to cover some reagents. Reagents means very basic reagent. So prior to go to the reagent, I think that we should discuss some physical aspect of the redox reaction, and then we should understand that what type of reagent should be considered for an oxidation reaction. Okay, so we have to understand their potential, and then we should move towards reaction. Because if we don't have any idea about the potential, reduction potential or oxidation potential of any species, I think that there is no meaning to exploit all those reagents for any reaction. Okay, so that is very much important. And second thing is that how we can find out the reduction potential and oxidation potential by using Nernst equation. So I think that we should brush up our memory. In the next class I will do that. And okay, so fine, goodbye, thank you. So in the next class we will look into those advanced things. Okay, we will move slowly. Okay, so thank you so much. Okay, very nice.